Okay. So let us start the assignment for week 10. First question is, I'm just going to draw a figure first. So this is actually h of n. All the values are, this level is 1. This is h of n. This is the direction of n. 0, 1, 2. For this is x of n. So it also has two values. This is 0.5. Direction of n. So we have to find the values of yn, y0, y1, y of 2, and y of 3, where the signal y of n is equal to x of n convolution h of n. So let me solve this. First of all, first sequence is like this. So h of n. Second sequence is like this. This is x of n. 1. This is 0.5. So x of n equal to 0.5, comma 0.5, that is n equal to 0 and n equal to 1. H of n equals to 1, comma 1, comma 1. So for n equal to 0, n equal to 1, and n equal to 2. So we do the convolution in this way. Zero point 0.5 for n equals to 0 and n equals to 1, it is 0.5. Similarly for hn for n equal to 1, this is the hn, this is the xn. There are 1, 1, and 1. So in this way we can divide it. So this is 0.5. The next one is 0.5 and here it is 0.5. This means 0.5 and from this it is 0.5. There is another 0.5. So y of n will be, first sequence is 0.5, second is 0.5 plus 0.5 equal to 1. Next one is again 1, last one is 0.5. So y of 0 is 0.5, y of 1 equal to 1, y of 2 equal to 1, 3 equal to 0.5. Now the second question. So again, I'm just trying to figures first. So this is x1 of n. This is x2 of n. The value 1, right? This value is 0.5. So 2 minus 1, 0, 1, 2. This is n. Similarly, this is 1 and this is 2.5. 1 n. So the question is determine y of 1 and y of 2, y of n equal to x1 of n plus 3 x2 of n. So y1 equal to x1 of 1 plus 3x2 of 1 and 3 into x2 of 1 is 3, x1 of 1 equal to 1 So y1 equal to 4. Similarly, for y2, all the syntaxes has just become 2. Y2 is equal to x1 of 2 into 3x2 of 2. x1 of 2 is again 1 and x2 of 2 is 2.5. So this is 2.5 into 3. So this is 7.5. So y of 2 is equal to 8.5. Okay, now let us go to the next question. For x of n equal to a to the power n un 0 less than alpha less than 1 and h of n to u of n, determine the impulse response y of n. So x of n equal to alpha n un and h of n equal to u of n. Y of n will be x of n convolution h of n. This is equal to k equal to from minus infinite to infinite x of k to h of n minus k. K equal to 0 to n alpha to the power k. This is because graphically we can see that This is u of k, then this sequence is u of n minus k. So it will be for k equal to 0 to n only this region. And it starts from 0 because this sequence starts from 0. Now let us go to the next question. With signal sub n h1 of n, and then it goes to h2 of n, then it sums up. Then it is h3 of n. The output is y of n. So question is, what is y of n? There are four options. First option is x of n convolution h1 of n convolution of h2 of n plus x of n convolution of h3 of n. Option B is x of n h1 of n h2 of n plus h3 of n. Option C is x of n convolution h1 of n convolution of h2 of n convolution of h3 of n. So we solve it. The system is x of n. It goes through in the first branch, it is h1, then it goes through a box h2, and then it sums up with another branch, that is h3, then it is out. So for this first branch, it goes like this. In the second branch, the same signal goes through this box. And then these are sums up. So first, the first branch is xn convolution h1 of n convolution of h2 of n, and, and then there is a summation. Summation in the third branch is h3 of n, that is convolution of with xn. So this is the output here. So this is y of n. So this is the answer. So the right answer is option A. Now let us go to the fifth question. Option A, direct delta function. Restricted delta function. Fourier delta function. Kronecker delta function. So there are two types of delta functions. First one is direct delta function. And the form of direct delta function is, if I took an integration over this del x, it will be equal to 1. So basically, I want to this is equal to plus infinite if x equal to 0 and 0 if x not equal to 0. And there is also Kronecker delta function. For which delta I equals to 0 if I not equals to 0, 1 I equals to 0. So here is it is given that a discrete time. So for discrete time delta function, this is Kronecker delta function because it takes a finite value 1. Del I takes the value 1 for I not equals to 0. I equals to 0. But for direct delta function, it actually del of x, that is a continuous time of signal. It's not a ith index, that is a continuous variable x. So the right option is Kronecker delta function. Now let us go to the sixth question. Is impulse response of unit step function u of n is option A del of n, option B q of n, option C del of n into u of sorry u of n, option D equal to 1. So impulse response means the channel Hn is del of n. The system's response is del of n. So the output will be always h of n convolution x of n. And x of n is unit step function here. So x of n equal to u of n. So y of n is equal to del of n convolution u of n. And performing convolution with respect to del n with any signal un just returns the same signal u of n. So it actually returns the same unit step function here. So y of n equal to u of n. So correct option is option B.
आजकल एक सब्जी देते हैं खाने में। हाँ भाई, रोज वही वही सब्जी। आजकल रोज सेम सब्जी दे रहे हैं खाने में। अरे इसने मौत के पास चला गया। अरे मालूम। काली इसलिए काली को तो भाग गया ना, देखा ना। गैस में तो भाग गया काली को तो खुद। रोज का सेम मेन्यू क्या है भाई?
So question number 7 is if there is a periodic signal x of t has a Nyquist sampling frequency
गाड़ी एकदम ऊपर ही था गाड़ी हम लोग का
of 1 megahertz,
अरे आइस ना ऐसा क्या करते हैं
what is the
मार दिया अरे दोस्तों का मजा और बिना
Nyquist sampling frequency?
और किसी को बस आलू बोलते आलू पता ना आलू उनको बोलते हैं अरे मेरे को भी स्विमिंग आता है मुझे नहीं बताया अरे तो मैं मस्ती कर रहा था लड़ाई
Option A is
मैं बोला मेंबर को
1 megahertz,
तो मस्ती कर रहा था
B is
और भी कौन बोलता
2 megahertz, option C is 4 megahertz, option D is 5 megahertz.
अलग तो है तो आता है इन सब में कैसे मिलेगा रॉन्ग मैटर फर्स्ट टाइम खेला सिर्फ फर्स्ट टाइम भूल यही करता हूँ और भी खाने को भी तो Hmm. Oh,
Okay, so we know that x sub t has a Fourier transformation of this format x of j omega. Similarly, dx of t dt is j omega also j omega. So clearly in frequency domain, only the phase and amplitude changes. So the Nyquist state will remain same. So it will remain 1 megahertz. Correct option is option A. Another way to visualize this that this differentiation is a linear operator. And a linear operator does not change the frequency. So it will remain the same frequency, and so the same Nyquist rate. Okay. So the last question: if x of t is a signal with fundamental frequency of 40 gigahertz, then compute the Nyquist sampling rate for y of t is equal to 40xt plus 4x of t minus 4. So again, the signal xt has a frequency of 40 gigahertz, and there is another signal x of t minus 4. So it will also have the same frequency, 40 gigahertz. The reason is the signal is x of t is time shifted by t minus 4. It only affects the phase, but no frequency change. So for the signal yt, that is actually 40xt plus 4x t minus 4. For this, the amplitude is only magnified, and for this amplitude plus phase information has been altered. So on and above, yt has a changed amplitude and phase. but yt has the same frequency. As x of t. Now, xt has a fundamental frequency of 40 gigahertz. So xt has a frequency of 40 gigahertz, but yt will have the frequency of 40 gigahertz also. That is the fundamental frequency. So the Nyquist centigrade will be 2 into the fundamental frequency. So that is 2 into 40 gigahertz. This is equal to 80 gigahertz. Okay. So this is the answer. So this is all for today. We will meet in the next Tuesday.